All right, so in our previous lesson, we talked about similar figures and the attributes or characteristics that those similar figures have. So if the problem tells you that the figures are similar, that means that they have corresponding sides, which are proportional, and corresponding angles, which are congruent. So just so you guys know, every single triangle is not similar to every other triangle that you see. Every rectangle is not similar to every rectangle that you see. In order for them to be actual similar figures, we have to make sure that their corresponding sides are proportional. So what we're going to do today is we're going to prove it with the math. So we're going to say that similar figures, again, are proportional. That means that the ratios of their sides are equivalent. So we have a couple of our steps here on the right-hand side to help guide us through these problems. So the first thing, in case you forgot, when we talked about our similar triangles or similar shapes, they have to be facing in the same position. So if these triangles were not facing in the same position, we'd have to draw and rotate and make sure that we can identify the corresponding sides. So right now we can actually see that these are in the same position. So this, what we're going to do is we're going to write a ratio for this first triangle and compare it to the ratio of the second triangle using those corresponding sides. So the first thing, I'm going to read my directions over here. These are my steps. So the first thing I'm going to do is choose any two sides to write a ratio. So I'm going to look at this first triangle, and I can use 4 to 8, 6 to 8, 6 to 4, 4 to 6. I can do a bunch of different combinations. But I'm just going to say 6 to 8. And what I'm going to do is I'm going to use different highlighters so I can help with my corresponding sides here in a minute. Okay? So if you want to label, we can say blue to pink, if that helps you out, because how we are using those colors to help us out. So in this triangle, my blue line represented 6, and that could be inches or centimeters or feet. We don't really know, so we're just going to write the number 6, and that pink is going to be 8. Then my second step says write a ratio for the next figure, so that second triangle, using the corresponding sides. So again, they are facing the same position. So this line segment right here is in the same relative position as this one. And if you look, is the 6 or the 12 corresponding with that side length? And hopefully you said the 12. Okay? So again, if we're comparing blue to pink on the left, we're going to compare blue to pink on the right. So you can label this to help you out. Okay, so we have my ratios. Well, right now, 6 to 8 is not the same as 9 to 12. So let's see our next step. We're going to simplify or reduce the ratios, or we could divide them into decimals. So we just want to review with how we can simplify. I'm going to keep these as fractions. And here's the deal. If they reduce to the same, that means they are similar triangles. Because remember, proportional just means two equivalent ratios. So we need to see if these ratios are equivalent. So 6 to 8, I'm going to look at that first. I can divide both of these, reduced by their common factor of 2, and that gets me 3 to 4. Then 9 to 12, I can reduce by their common factor of 3. 9 divided by 3 is 3. 12 divided by 3 is 4. So if they reduce down to the same thing, we would say these triangles are similar. So we can say yes, similar triangles. Because the ratio, their simplified ratios are the same. So just because they're triangles does not mean that they are similar. You have to reduce them down. Write your ratio for each and make sure they reduce down to the same thing. So if you would pick 6 to 8, maybe you'd pick 4 to 8, and then over here you would pick 6 to 12. Those would still actually reduce down to the same thing. Or maybe if you did 6 to 4 or 9 to 6, as long as those reduce down to the same thing, that would be okay. Okay, so sometimes you're going to have to prove them all. So just something to think about. All right, let's try another one. So this one, we can see that these are both triangles, but we can't tell if they're similar just yet. So if we visualize taking a smaller triangle and rotating it around and drawing it inside, that's what we want to do first. So if I I'm going to draw a little arrow, and remember to draw smaller shape inside the bigger shape. That will help us decide the corresponding size, okay? Because when you first look at it, you might fall for a trick and say that this 4 corresponds to the 14. But think about it. If you're rotating it, so the first thing I see is this 10 is going to correspond with that 20. So if we were to draw it here, rotate it around, be 10. So if this were rotating, think about it. This would be 10. Then this would rotate. Your 7 would actually turn all the way to here. And then the 4 would be here. Okay, so it's something to think about. And then, so if we use that 7, well, if we turn this, just like that, it's not going to be 8. We have to turn it again, so that 7 is going to correspond with the 14. Okay, so if I want to write a ratio for my smaller triangle, and again, if I do blue to pink, the blue was 7, the pink was 10. 7/10 is already reduced, so I can make that a decimal, 7/10, just like that. Because remember, we can write the ratio, choose any two sides to write the ratio, then we're going to write one with the corresponding, and then simplify. So 14 was in the same position as that 7, so we're doing blue to pink. And the 20 was in the same side, corresponding side with that 10. So we can divide this by 2, and that would be 7/10. Or if you wanted to change it to the decimal, so 7/10 is the same, or they reduce down to the same. So yes, these are similar as well. So these are similar triangles, and we wouldn't say just because they're triangles, they are similar triangles because their simplified ratios are the same. Now, before we get to the next one, I want to show you something as well. You might have actually already see this, but just in case you don't, you can tell from 10 to 20, I can do times 2. That's a scale factor. From 4 to 8, I can do times 2. And from 7 to 14, I can do times 2. So that means that this bigger triangle is literally double in size as this one, so we actually know they're proportional that way as well. Okay, so going back to those proportional relationships, remember proportions are just two equivalent ratios. All right, so look at these trapezoids. Again, if these are not facing in the same position, we need to take this smaller trapezoid and rotate it to draw it inside that larger trapezoid. So we're going to draw this smaller one inside. Now, another way you can see this, you can see that this is the shortest length, so it's not going to correspond with the larger length on this one. It's going to correspond with the smaller length over here. So short with short, longer with longer. So if we rotate that around, it doesn't have to be perfect, but we can do as best we can. So that 2 centimeters is here. That 5 centimeters is going to go up here. And this 4 centimeters is that here. Or if we turned it, we can see that it's going to be right here. Okay? So again, you can use any two sides that you want. I'm just going to do the longer base, and that corresponds with this 5. We can actually see in that picture right there. And that smaller base of the trapezoid corresponds with that 2 now that I've drawn it in, and I can do like that. Remember, the bases in the trapezoid are the parallel line. Okay? So again, we could have done 8 with the 20 or 8 with the 16. It doesn't matter which two sides you do, or 20 to 16, but I'm just kind of showing you different ways. Okay? So you might have picked different numbers with that, but that's okay. We can prove the math. So again, I'm going to just say blue I'm going to do pink to blue on this one. So pink to blue. So my first one on this one was 20 to 8. So I'm going to compare the same ratio. Now when I'm comparing the ratios, I have to do the same order. I can't do pink to blue on this larger one and then blue to pink on this smaller one because that's a different corresponding size. So we have to make sure we write it that way. That's why I label mine over here. So this is 5 to 2. Well, 5 to 2 is already reduced, but 20 and 8 can both be divided by 4, and we get 5 to 2. So again, these are similar. It's going to say yes, the trapezoids are similar, not just because they're trapezoids, but because they simplify to the same ratio. So we want to get you in the habit of writing these out so you understand the why behind it, rather than just saying yes or no. Because sometimes, if it's multiple choice, they might say yes, but the explanation might not be correct. Now another thing you might see, 2 times 4 is 8, 4 times 4 is 16, 5 times 4 is 20. So that could be another reason we could say they have a scale factor of 4 from the smaller trapezoid to the larger trapezoid. But again, this is the main content because sometimes you won't have that scale factor. It's easy to see, but we can see that when the ratio is reduced down to the same, they are going to be proportional because they are equivalent ratios. All right. Now let's look at one last problem before you have some independent practice. It says, which of the following triangles shown below is similar to triangle ABC? So all the triangles are facing the same position, so we don't have to think about rotating these and drawing them like that. So the first thing I want to do is I'm just going to use, again, I'm going to write a ratio. So I'm going to say this 4 corresponds with this 7, with this 6, with this 5, and with this 7 and 5/10. Okay, then I'm going to use pink again, so this 3 corresponds with this 6, with this 4.5, or 4 and 5/10, with this 4, and with this 6. Now it doesn't matter if these match up with one another, we want one of these to match with this. Okay, so let's see how we're going to do that one. All right, so if I say I'm going to compare the pink line segment to the blue. My pink was 3 and my blue was 4. Again, it didn't matter if I did 3 to 4 or 3 to 5 or 5 to 3 or 5 to 4. You're just picking any two sides, okay? So pink to blue, well this pink, I'm going to make a ratio for all of them, pink to blue. And they have to reduce down to 3/4, or 3 to 4, excuse me. Or you can say the decimal equivalent of that is 75 hundredths. Think about money. 3 out of 4 quarters is 75 cents. Okay, so this pink is 6, and its blue is 7. I'm just going to set these all up. This is 4 and 5/10 to its blue is 6. This pink is 4 to its blue is 5. This pink is 6. And its blue is 7 and 5/10. Now here's where some students stop. They go, well, I don't see any of these as 3 to 4, and they're actually already reduced. So remember, we can convert our fractions to decimals, okay? Now normally we would do long division, but just for some time's sake, I'm going to remind you how we could do this with the calculator, but remember, you would have to do this on your own. So if we said option A, if I said 6 divided by 7, that's how I would write it, okay? But we'll just use the calculator to double check it. So 6 divided by 7 is equal to about 86 hundredths. So I'm going to say about 86 hundredths, because 7 is in the thousandths place, tenths, hundredths, and then thousandths. Well, we want 75 hundredths, so we know that it's not A. Again, remember, you'd have to divide this out, but we'll just go ahead and look. We are only looking for 75 hundredths. All right, so this one, if I said 4 for option B, 4 and 5/10 divided by 6, remember I can have a decimal on the inside, that's okay. If we did long division, which you know how to do, but just for time's sake, we're just going to check it in a calculator. So 4 and 5/10 divided by 6 That gets me exactly what I want, 75 hundredths. So it looks like it's going to be answer choice B, but let's prove the other one's wrong. Okay, 4/5, 4 divided by 5, or 4 to 5. I shouldn't say 4/5, it's technically a ratio, not a fraction. 4 divided by 5 is going to be 8/10. And remember, we're looking for the decimal equivalent of 75 hundredths. Okay, so far it looks like it's B, but let's just prove these wrong. Answer choice D, when we said pink was 6 to the blue, which was 7 5/10. Remember, if we were doing long division, we'd go 1 to the door, go inside and slide 1 more. So it's really like 75 on the outside and 60 on the inside if you had to do long division. So 6 divided by 7.5 is 8/10. And just to prove that, because we rewrote it, 60 divided by 75 is 8/10. So really and truly, C and D are similar to one another, but we wanted to know which one was similar to A, B, and C, so it had to reduce down to the same thing, so it's going to be this one right here. Answer choice B. Okay? So again, if you need to rewatch this video just to review, make sure you understand what's happening before you get to the problem. That's what we're having those videos here so you can review them. And again, let us know if you need help. Good luck.